In this lesson, we're going to continue with problem solving in sinusoidal curves. So sometimes we're going to have to figure out equations, we're going to solve some problems. We're going to deal sort of with the word problems, if you will. So we look at the first example, and today's just example, there's 3 of them. We have Candace. She's holding on the end of a spring that's attached to a lead ball. As she moves her hand up and down, the ball goes up and down. Without concentration, she can repeatedly get the ball to reach a maximum height of 20 and a minimum height of 4 from the top of the surface. And the first maximum occurs at 0.2, and the first minimum at 0.6. Can we figure out the equation that represents this? So there's tons of important information in here. We get ourselves a max and a min, which tells us right off the bat that, hey, we got ourselves A and C. A is max minus min over 2, so 16 over 2, which is 8. And C is max plus min over 2, so 24 over 2, which is 12. She's also told us that the first maximum occurs at 0.2 and the minimum at 0.6. Well, a max to a min is half a cycle. If it took us from 0.2 to 0.6, in other words, 0.4 seconds for half a cycle, we can double that and we get a 0.8 period. Well, that's handy because if I know the period, I can get K. K is 360 over 0.8, which is 450. And one more thing, it tells us that the first max occurs at 0.2 seconds. So if I were graphing this, at the point maximum right there, and I think about cos curves, I know that a cos curve is supposed to start on the axis, but it's over a little bit. It's over 0.2 in fact. So I've got myself a horizontal translation. So let's fill our parts and pieces in. 8 for A, cos. K is 450. We moved it to the right, 0.2, so minus 0.2. And then C is 12. And there's our equation, just by using a little bit of problem solving from what they gave us. Okay, part B, determine the domain and range of this function. So we're going to go back a little bit here. Domain and range we can figure out pretty easily. Domain's kind of cheating in some ways because as far as we know, she keeps going on and on forever and ever. Time starts at 0. It doesn't tell us when she stops, so we can say it keeps going. Our range, we've also talked about before that we can find our range by using our max and our min. Well, it gave it to us in the question, right? The maximum it told us in the question was, oh, it actually didn't tell us what the maximum was, sorry. Oh yeah, it did, back there, 20. Max is 20 and minimum is 4. So 4 to 20. Done. Quick. Okay. Part C, what's the equation of the axis and what does it represent in this situation? So, the equation of the axis is C. So y equals 12. What does it represent? We've talked about the axis being your average. Okay, this is the average height above the surface. I don't know what's above. And then part D. Part D says what is the height of the ball at 1.3 seconds? So now we can use functions. So we're going to figure out what's happening at 1.3. So using our equation, we're going to replace the x's. 8 cos 450 1.3 minus 0.2 plus 12. Okay, we can simplify this stuff in the bracket if you want to, okay, or just use brackets in your calculator. If you punch it in, we should get 6.34 centimeters. So now we're actually using our equation, not just building it, but using it for a purpose. We can evaluate where that ball is at certain points along the function. Okay, let's try another one. I hope you pause the videos, try them yourself, see if you can figure them out, okay? An oscilloscope measures current. It's hooked up to an alternating current circuit showing a sine curve. The device records the current in amps on the axis in time in seconds. At t equals 0, we're at the maximum of 4.5. And at 1/20th, the current reaches a minimum of negative 4.5. Let's figure out our equation. So what do we got? We got maximums. We got minimum. Well, together that gives us our A value, right? 4.5. We can also do the same thing for C. And the nice thing with these two is they'll cancel each other out, and we'll get 0. We know that the first maximum is at 0 and the first minimum is at 120. So max, and then min, and this is 1/120th of a second. Actually, it's a negative, so it's probably more accurate here. Okay, so it takes that long to do half a cycle. So a whole cycle would be 2 times 1/120th, which is 1/60th. There's our period. That will get us K. K will be 360 divided by 1/60th, which you know from fractions means we're dividing by a 60th. How do we divide fractions? We flip and multiply, right? So think of it as that. And you calculate for that one, 21,600. Hey, we're making an equation. Well, looking at the picture I drew, just even a tiny little sketch of a picture, I've got myself a cos curve starting at the maximum, no phase shift. So A is 4.5 cos 21,600x, no phase shift, so I don't need K at all, or should I add D at all, and my central axis is also 0, so that's my entire function right there. Okay. What current is passing through the circuit at 1.5 seconds? So way down the road, because remember this is like 1/60th right now. I want to know what happens at 1.5 seconds. So we're using our function. So f at x equals 4.5 cos 21/6 times 1.5. Into our calculator it goes, and I got 4.5 amps. So it turns out that at 1.5 seconds, we're at the maximum. Okay, that's the second one done. Third one, last one. Can you guys pause it, try it yourself so you can figure these things out? Helps to draw those little pictures, circle important information, that kind of stuff. So a flagpole, it sways back and forth in high winds. The top sways 10 centimeters to the right and then 10 centimeters to the left, back and forth and back and forth. And it does that 240 times every minute. At t equals 0, the pole is momentarily at its resting position, then started moving to the right. So what can we figure out? Well, we know the maximum. If we think of this as we're going to the right and then back to the left, our maximum would be 10 to the right and negative 10 to the left, right? So 10 plus negative 10, oops, not plus, minus 10 minus negative 10 over 2, amplitude is 10. Central axis, well, common sense says it should be 0, and it is. It does this thing 240 times every minute. So, in other words, my K value, I need my period for. So I got to figure out how many times, how long it takes to do one cycle. So I know 60 seconds in a minute. If I divide that by how many times it swings back and forth, I can tell you that it takes a quarter of a second to do one cycle. Well, if I know that, I can get K. 360 over a quarter, or 360 by 0.25, comes out to what, 1440. Okay, make my equation. I'm looking at my picture. My A value is 10. I think this looks like a perfect sine curve. It's starting on the central axis. So we haven't used it in a while, but sine makes sense here. My K value is 1440. I have no translation left or right because I'm on the central axis where I'm starting. So I can put the X in there. And my C value is also 0, so there's our function. Done, that's it. Okay, part B, How does the situation affect the domain range? Okay, what's our domain range? We can figure that out. Our domain, well, time starts at 0 and goes from there. As far as we know, it's going to go back and forth until the winds die. Our range goes from a low of -10 to a high of +10. Goes back and forth, always between those two values. And then part C, the wind speed decreases so that the sway is reduced by 20%. What's the new equation of the function? We're going to assume that the period stays the same. So what changes? Well, if we decrease by 20%, instead of swinging left and right 10, we're only going to go 80% of that, right? We're only going to go left and right 8. So what's going to change? Well, my A value is now 8. My C value is still 0. My K value is still the 1440. Only that's going to change is how far back and forth I go. So my equation is 8 sine 1440x. Everything else will stay the same. Okay, that's our last lesson this unit. Problem solving, thinking about things we can gather from the questions. Maybe drawing little pictures to help us understand what's going on here. Just get some ideas of periodic functions or equations and how we can make predictions from them.